actually published any type of videos in the past, it must be 4 or 5 weeks now. I've been quite busy with a few other things. Just a little bit of a coming soon. I've been working with the student chapter, so some of the exoskeleton stuff that they've been doing. We're now preparing for the up and coming Exo Games. If you've not signed up, why haven't you signed up? See you there. And also I've been working on personal, well, not personal, but bigger projects. So new types of exoskeletons in conjunction with some of the bigger friends that managed to get over the years. And also I won an ASTM award. Amazing. Got to tell someone. I've got to tell everyone. But what I do want to do today is to just push this back on track again. Now, I was asked over a few days ago about doing Matlab Simmultibody, and what would you do if you were going to do 3D printing? And what I mean by that is travel, the rails. What's a good way to get started? And I thought what I could do is set up an example and see if we can set up a travel on a rail. And then in theory, when we know where everything is within that rail, we could continue to construct further and further and further. This just gets more and more and more in depth as we go along. So what I'll do first is just shrink you right down to here. Let's give it about like here. Okay, so this is a model that I've downloaded from GrabCAD, done by Rosa company, and this is just as far as what I can tell, a prototype 3D printing system. It's quite cool, quite like it. It's as anybody who follows me on this YouTube channel knows, I'm not a big 3D printing guy, so I'm not well accustomed to the process with it. But how do we set this up? So we have rail, and we have a single extrusion rail, and we can also control the outlet of this travel of the hot end as well. So what I would like to do is to see if I could recreate this in Multibody and get it to travel from left to right. There's a few things I need to do. Obviously, like I've done before, I need to export each one of these into step files. So like before, I can pull this up to my extrusion, for example. And then I go File. And just in preparation for this, I've already exported and export it as a step file. So I've exported my extrusion, I've exported the rail. Now I've exported this rail as an overall piece, but what you'll notice here is the rail's been modeled with Nylox. This looks like a nitrile hyperelastic. There's also a bearing on the inside of the actual travel piece. So in essence, this thing will move backwards and forwards smoothly and with very little resistance. Okay, so I'm going to leave this open just because, for example, I need to know where everything sits. So if I come back here, if you remember some of the stuff that we've done before, it's about where everything clamps to it. Now if I just spin this round, I'm going relatively quick because I don't want to mess around with this. Spin this round, we can see there it clamps to the end of it. So I'm going to use the end piece and end piece and use them as key points for mounting. So what I'll do first is call up to my MATLAB, and then let's get into it. Let's go straight into it, no messing. Simulink model. Nice. Now into a blank model. And so we're into our blank model here. So let's go to library browser. And obviously within the library browser, we'll be able to pull all the key files. Now you'll notice I've staggered in, then staggered out, and staggered in, and staggered out. This is purely because when you first load up MATLAB, everybody's using this now. You know it takes forever to come to pass. So what I'm going to do first is I'm going to bring in a world frame. Oops. So I'm bringing in a world frame, and me typing it in is now going into the library, making sure I've got that all important license to allow me to do what I want to. Any minute now. This is the only problem with it. It takes its time. We're always waiting for it to respond. The beauty is once this first initial run has been completed, we then know it can at least repeat that process. So like now, if I speed this along now, so let's go mechanism configuration. So we'll go mechanism configuration. He's like, I'm gonna in a minute. Oh, wrong one. Mechanism configuration. And then what was the all important? And if any of you have done this before, you'll know this is a solver config. So bring in a solver config, spin that round, and now we have all the big boys for the party right there. Now, don't forget, Matlab and its behavior wants to know where it moves. So it wants to know what is stationary and where else it will move. Now, for this short piece, all we're considering is this thing traveling along the actual rail. I actually think I probably got that wrong as far as the system works, but I'm not bothered because all I want to do is just look at what happens if this could travel backwards and forwards along the rail. So in that much respect, that would imply that the extrusion is actually a dummy piece, which is fine, but let's do that. So I'm going to go body. Oh no, it's file solid. Sorry, file solid. And I'm just going to rename this extrusion. And then I'm just going to just realize what I've done there. No laughing. I'll go into my desktop, onto travel, and here I've got my rail, my linear rail. So I'll click open. I'll come back to it in a moment. So I'll go F5. Bringing in that key point should now show me a nice extrusion for me to operate with. Let's not forget, the first thing we need to check is where is that all important, oh my days, look at that, triad system. Oh my goodness. It's been modeled in a really awkward spot. So we may have to edit that. I always like to edit. I like, if I have to start somewhere, at least start in the middle. The other thing is as well, extrusion tends to be aluminium. So I'm gonna make this. I'm gonna presume this. Oh, sorry. 1 second. I'm just pulling out aluminium's density. And the density. Okay, so the reason I say that, if you remember, under inertia, I'm going to put in a custom density, and here it wants to know by cubic centimeter, by kilogram per meter cubed. And if I just drop this to gram, according to my reference of alloys.com, 2.7 is the density of this material in grams centimeter cubed. Click apply, and I'm just going to update that to ensure that all my center of gravity is correct. I'm going to go to graphics. I'd like to just give this a slight change in the coloring. I do this just for my own peace of mind, because I often get confused what the hell I'm looking at. So click OK, then apply, and then I'll do F5. So now we've got an aluminium style looking. And then finally, I'm going to add a frame. I just put this frame on here because I want something to give me COG. And then I'm just going to go, let's just go apply. Save that. What's important there is we see where that COG is traveling. So that COG is good. So it means it's going to go backwards and forwards. We can use that to our advantage. Turn off R, then go apply. Then boys and girls, we are looking pretty good, right? So now spin that round, and then I'm just going to stretch this over. And oh yeah, just pull it out. I just, you know, dyslexia, just love to add letters. Stamp that into here, and then I'm gonna save. Good practice, we save, because the trouble is things go wrong. So let's just call this travel. and you're racing through it, and you kind of go, this is good, that is good, and you forget. So really good practice to just hit save. And right, so let's move on. Come back to the actual piece. Now, if anybody's curious, this is Autodesk Inventor. I'm a great lover of Autodesk Inventor, but you can see there that this travel here has been interacted to just pretty much go that way. Now, what I can do is get even the rollers operating, but for this, I'm just going to look at it traveling backwards and forwards. This is, if you will, this is the dead basic, the first step of getting this running a little bit more successfully. Now, rather than just running into typing, I'm going to go straight to my multibody, go to my joints, and within my joints, many things I've got going on right now. Is it bush? No. Constant velocity? No. Cylindrical? Nope. Really, it's prismatic. I'm just looking. There it is, prismatic there. And I'm going to bring over my prismatic joint, and this is going to allow it to travel backwards and forwards. But do not forget, everything travels along these Z axes. So now what I'm going to do is introduce, let's call it my float. It might not be called float. I'm sure a lot of people will be annoyed with me for saying that, but it may be. I don't know what it's going to be called, but I'll call it float. I was just thinking because it moves backwards and forwards. So I'm going to go over to here, and then I'm going to go to my Mini V gravity set. Which, yeah. Okay. Oh. Mini V gravity set. Hang on a minute. What? Have I... Oh my days. Okay, let's try that. Oh, that's not looking good. Okay, let's come back. Let's try that again. Mini V gravity set. Okay. Oh. Look at that. Due to errors. Okay, so there's something wrong here. So I'm going to try it again. What I'll perhaps do is try and take it out. It's never the biggest fan of taking out these things as a full piece, as a single part. But I'm not fussed. I just want it out. So let's have a look. If I go step, let's look at objects. It might not be happy with me trying to do this, but give it one more try. If this goes wrong, we'll go another way. We'll file solid. So the errors in diagnosis. Okay, yeah, it's not happy with me trying to do this. So what I'll do is see, the trouble is we may have to construct the entire thing, which is a little bit of a side area, I won't lie, but it is totally not impossible. But let's have a look at what other options we've got in the file types. We have step. We have part. Okay. So I'm going to try exporting out and see if it'll allow me to export as an object. A friend recently told me it will now import all different types where you go. That is very cool. Very, very cool. Let's go IGES. Put an IGES there. And then I'm now just going to come back and then go export and do again, file type. I'm just trying different ones right now because it's not playing ball for me, so let's just try a couple. So let's start with IGES, see what it does with an IGES. Look at that, right, let's bring that back, wasn't happy there. Still not happy with IGES. Try an OBJ. Okay, so To try and fix this then, it's not going to allow me to take it all out as one piece, so I'm going to have to build a temporary assembly for this. I'm not going to build the whole thing back up. Probably just going to build a few pieces so you can get an idea of what it is that I'm doing, and then we'll use a central piece as a point for travel. So let's just put this into perspective then. Let's go first piece first. Let's go top, double click in, and I'm going to go back, and then I'll go, so I've exported these piece by piece, and I'll just go by plate, F5. And then by the plate, what we can see here is this. So if we just quickly refer to the actual model, that's the plate itself. So now what I'll do is just apply some frames. So all I'm going to do now is just apply my frames on. And so I'm going to put frame on each one, and I'm going to put the bolt in position. Okay, so everything's in position. Just placed all of them on, and now if I just add one last piece coming to here, I'd like to add a COG to the point that I'm using. So let's go COG, but the trouble is, don't forget, let's just double check that it's moving like we want it to, and amazingly it actually is. There's very little to change here, because don't forget, everything defaults to Z. That axis is within the right axis, so I'm going to click apply. Drop off my R, and go F5, apply, then OK. Oh! Did that just do everything? Yeah, there we go. COD. I need to change that, silly sod. So come to here, go on to there, and then we will change COD to COG for center of gravity. My goodness. I had one job. Okay, and now what I want to be able to do is add in the further. So we'll go file solid, and all I'm doing now is I'm bringing in my M5. M5 bolt, come to the top, snap it in, key point here, and bring it to my desktop, to travel, to float, and we have an M5. This one's dead easy. I mean, we did a few like this before, but this one is really easy. So let's go F5. We snap that right into there. And all I'm going to do here is add a relationship. I'm going to drop off the R in a moment, but I'm going to add a relationship here. Click boom, apply. Make sure my axes are in the right orientation that I want them to be in. Z, I would like to be on this key component here. And at the moment, Z actually sits there. So really, I need this to be X. Obviously, it complains because it's what it does when it thinks you're doing something a little bit crazy. So all I've done is flip that round, click apply, and then OK. And my R in this case is going to change, but this is just so I can bolt this on. So what I'd like to do quickly is just take a look at my model. And update onto model, and obviously nothing's working yet, so don't be alarmed if you look at it and go, that's not what I was intending for it to do, because you're right, it's not, but you've just got to make sure that the piece is actually doing what, yeah, because it's actually saying, now what are you doing? It wants me to connect stuff, so blimey heck, so I'll put it there. He wants to see where things are going, which is fine. All I really want to see is everything in the right place on here, and you can see there it's actually not. It's upside down. So all I need to do here is just flip that around, and the extrusion itself is actually out as well, which is not a problem. We're just going to shift it up because we'll use a rigid transform to do that. But first things first, let's flip that around. So I come over here, snap on. Where Z sits, we sit here, but let's push that into a negative Z. Then go save, apply. I'll drop my R off for this case. F5 to update, and apply, and then OK. Then let's bring that over here and snap you to there. And the reason I'm doing that is because now I want to be able to build these up piece by piece. So that's onto there. Whoops, Not like that. That to there. And we've got one here as well, splitting it round. To there. And then also that to there. This example has taken a little bit longer than I thought it would do. Just because it's ended up with a few extra bits I didn't see coming, which is this. The fact that I wouldn't be allowed to do what I was attempting to do in that single hit. I'm just realising I'll probably not add them just yet, just because I've got further things to add on to here. So, given where that actually sits, and what I'm actually going to do is, based on the actual piece that I've got here, I've got that to add on, which is this. Okay? Now, I can place it in a rigid transform straight from the tip of where that's sitting by the distance. So the distance of this is... oh my days. Oh my goodness. Go there. To there. Oh, that's not right. So the edge of that is... I'm just going to turn that off. I'm just being lazy. Over that point, and then we'll take it down to that point. Then we've got 4 mil, which is good. So if I come back, I'll come back onto here and click OK. And then what all I'm going to do now is I'm going to go RI for rigid transform. I'm going to bring that over to here. Now, the reason I'm doing this is because all I'm actually going to do is I'm going to shift along from my base to here. I'm going down in Z. If you remember on the transform systems, we ensured that Z was going to be our go-to value. So I'm going to go down in Z by 4 millimeters, and then go OK. And now we'll go file solid. And now what I do is I bring in my, I actually think it's a washer. I don't really know. Onto here, and I think, oh, it's a spacer. It's a spacer. Right, so onto here, and 3, 2, 1. Oh my days, it's not the most complicated geometry in the world. Come on, what's going on? Click OK. Oh my God. It's not even happy with this spacer. I should have really done my own geometry here, but I was rushing. So let's try this again. So let's go spacer. Spacer. And I'm going to go export. And I'm going to go step. Let's go OK. Space on the step. Save. And then let's go back to my point. Go to my spacer. And then OK. Is that going to come in? Does not like that. Look at that. Does not like that at all. How annoying. Well, I'm going to pick... I want something to actually bind to. Because I like just what we're doing here. So, in fact, let's take this. What is this? This is... okay. Yeah, let's take this. So, I'm going to take this. And I'm just going to export... And really what I'm trying to show you here is sometimes you're going to get yourself in a position where you've just got to, you've got to try and build, oh, look at that. Now, look at that. Now, that's because there was something wrong with the actual original geometry when it was modelled. Look at that. That is damage, man. That is serious damage. We're going to stay with a, I'll go with the custom density. Let's go custom density. Let's just leave it like that. The trouble is it's not going to be the most happiest in the world, but it allows us to do what we want to here. So I'm just going to try. Let's take a look at the updated model by attaching that to the center of gravity. So we upload to the model, and this is now what we see. What we see. Right, so you look there. See how it's gone? It's gone that way, wrong way. So what I'm going to do is quickly pan back to here, and then where I've gone positive, I'm going to go negative. Come back to the overall piece, and then I'm going to simply update. Boom. So now what we've got, and we're down here. The bolt itself still looking a little bit scabby there, isn't it? So what I might do is just look back at the plate. When I originally housed these on the F1, I'm sure I chose the inside of the face, or did I choose? Knowing me, I've not chosen the right face. So let's come back and just have a quick look. Go into here. Oh, look at that. It's okay. I can change that. Because once you get a good piece of geometry in position, setting these things up is so easy. You know, you can easily change something. Something goes wrong, you just change it. Just hit a button like that. Now, that's a little bit more like what I'm after. But you'll see there how that that 4mm that file solid is now changed in its relationship, which way that was going. Interesting to see why though. If we could just look back at that model. How interesting. Okay. So let's pan that back. This now claims, so if I'm just going to, let's just push you to 8mm. Ah, I know what this is. So this is because where I'd measured from on the original model was slightly different to where I'm measuring to now, which is not perfect, I get. So all I'm doing here is just kind of bluffing it. Okay, but what you'll see now is I'm starting to build up the actual pieces. And what I'd like to do now is emulate the same process. Pull you across. Pull that off completely. Let's pull you across like that. Like that. And like that. Spin you around. Like that. And let's get you to roughly there. Pan you over to there. Something like that. Bring you down. Pan you over. And then bring you across. Something like that. And then, I mean, anybody who knows me, you'll know that I actually do like to have tidy representation when you're doing things. I think otherwise it looks clumsy. But what I'll do now is right click. And I'm going to create a subsystem. There we go. So now we know that everything in here is my float. A little bit longer than we're intending, but we're looking a lot better right now. Okay. So if I was to simply hit run, this is what we're going to get. So let's bring this back. Let's just hit run. You go and you look and go, oh my days, what's happening here? This one needs fixing. We can fix that. But this is what we get under run. So what's it say under? Density was not found in bolt, and float top. So let's go bolt density. And we'll use custom density, apply, done. If you're doing this properly, do make sure that you're using the right values or the right representation. I found my extrusion value, or else when this report runs, it will be all over the place. Again, just checking my inertias onto inertias, and then again onto my bolts, onto here. Density, apply, okay, and then on here, and here, let's go, density, custom, onto apply, okay. I've just realised that is actually the wrong way around, so it should be there. So if we bring that back to the original, it should now look a little bit more like that. So now, if I hit run, I'm not actually imagining much will happen here. Yeah, so we're still in area. What we float. Oh, so my float itself, which is here. Density not defined. Again, you'll notice though my densities are very light here. But bring that back and then let's run. What we got now? Right, and that's what we get. So what you'll see is, in a minute, bring us all the way back. If I just tab it forward, it just slides off the rail. It's doing exactly. Now Z is here. Gravity is in Z for our example, so it just slides off the rail. If you had to think of it like this, the rail is considered to be stood upright. And all it does is drops off. So what we now need to do is to tell it what we want it to do. This system will just operate. But if we say, well, no, you're not doing that. This is what you're doing. So I'm going to go prismatic actuation. Am I providing a force? No. Am I providing motion? You damn skipper. So now all I do here is go Simulink to power string conversion, or Simulink to PS converter, and all I'm going to do is come to here, snap on, double click in. First thing is my units. We'll get it moving. In fact, let's go millimeters. And input values for this. We'll go second derivative, because we know we're going to be putting in a motor. This is also going to be great because we can put in what it will do under different conditional states. So anyway, first things first. Let's go signal editor. 3, 2, 1. Yarp. So that signal editor's brought in, snapping it in onto my signal editor. Now don't forget the all important aspects of this. I need this system to interpolate when it functions. Given the size of this and given the length of this, I don't remember how long this bloody rail was. 1 minute. This rail is 500 millimeters. So we're sitting 250. So we're going to go minus 250 and then plus 500. So we'll go back and then forwards in our distance. Over that period of 10 seconds. So I'm going to come onto my scenario. I'm going to add one in. I've got a 10-second period. So over our first period, let's go over. Let's go 4 seconds. Within that 4 seconds, you'll notice there I just snapped on, but I'll go 4 seconds, and then I'm going to move 250. And then in that 10-second process, I'm going to go minus 500. Don't forget we're in millimeters, so it's the length of the actual piece. So let's take a look at the distance. That's what we're saying. Nice simple piece, but it allows us to just look at this thing moving. Close that off. Do I want to save it? I do want to save it. What do I want to call it? It's going to go in my folder, so I'm going to call this travel rail, or whatever, really. And the data that's gathered in is already set to scenario. We've already got it set to a piece. Interpolate that data. Let's go apply, and then let's go run. So let's see what happens. So I'm going to run. Oh, that's just a play. So I'm going to run. Okay, so we've got a complaint. Dynamic coupling with the prismatic joint, fewer degrees of freedom, force and torque. Automatically calculated. It was. Hang on, let me just make sure that's right before I make a statement. Right. So what it was saying then is, you made a statement, and it can calculate all this, but to really operate it can't do what you want it to. So what did I do wrong? I moved along by 250, but then I came back 500, but I went minus 500. One thing to remember is I assigned a COG to the rail. So if I come back to my piece and I come back to my signal, what this should be is not minus 500, but it should be actually minus 250. Because it is, I set that COG, if you remember. So now we're on 250 by 250. Right, so if we now go save, and then I close that off again, and let's do a rerun, shall we? So we move across, and then we move all the way back. Great piece, great easy process for it. Moves nicely, and I can control where it moves. And what can I actually get from this? So let's come back into my prismatic. If I come to my sensing, I've got actuation force, position. Or what if I wanted something else? What if I wanted speeds of certain bodies? I could go to transform sensor. Now, my transform sensor, what this does is this allows me transform. What this allows me to do is monitor just the body in space, and less of the joint. So then I come across to here and bring it up to here, and then let's bring that across. We'll put these all out in a moment, and I'm going to use a world frame to allow me to take a baseline, if you will. And then on here, I have crazy level of detail. Acceleration in all key aspects. Translation. Let's go for rotational sequence. Transform. Let's just go just a translation. There's just so much we can do here. So let's say just along Z. And I'll do a power stream. Oh, I'll do a power stream to simulate converter. Bring it to here. And another one. And another one. And all I'm doing now is snapping all these in. If you've done this before, you'll know how to do this. I'm going to go scope. And then we're almost done. We have our rail working. And to build up the printer to go even further, all I need to do is actually emulate exactly what I've done here, but another layer of it. It's nothing too sophisticated. It's nothing that we've not seen. So all I'm going to do here is come onto my scope. Scopes are good. They are not good for presentation pieces, but they're good to just take a look at what in the hell is going on. So I'll bring onto my 3 scopes, onto here, then click apply, and then let's take a look. So come back to my scope, and then let's run. So what was the bottom one? I can't remember what the bottom one was. Is that a force? I think it's a force. Actuator force. It's how much force it's got. Now you got to remember, the densities I've applied here are very tiny. But you see there that we've got a nice force for its reaction. I'm not convinced of that as far as the computing goes, so I'm just going to tighten up my results, come to my model settings, and I'm just going to bring myself to a time step which gives me a lot more confidence in my approach to what it is I want to do. So just juice that up to 6, run that over again, and then go, and then run. Come back to my main area. Now what we've got is something that looks... We have an overshoot, we have the way that it responds, and then it comes to a steady state. So that is how to build a rail. So, I hope you found that useful. I hope you found that really, really helpful. Setting up things in Simmultibody for doing extremely sophisticated simulations looks really intimidating, looks really difficult, but once you get into it, it's actually dead easy. It's just getting confidence in the process that you're doing. If there is any questions, don't be afraid to ask. Drop me a question in the actual comments. If you are a student, please do reach out. Come and see me. More than happy to talk you to sleep about Simmultibody. If you are a person who is interested in the exoskeleton side of things, we have a load of exciting things about to emerge. I don't want to spoil anybody's. I don't want to steal anybody's thunder, and I don't want to spoil anybody's fun. So I'm not saying a damn thing about it. But do keep an eye out for all these things. The student chapter are about to do their own stand at the University of Central Lancashire in June. So if you are around then, try and get there. What they're going to do is going to be massive. It's going to be so exciting. And other than that, what I'll be doing from now on is coming back to the actual channel and doing a bit more on project progress. Other than that, I hope you found it useful and have a great day.